Okay, in this phase diagram for water, what is being plotted on the x-axis and the y-axis? All right, what's on the x-axis? Good, the temperature. And then the y-axis? Good, the pressure. And what are the units for both of these? Bless you. Temperature is? Yeah, good, degrees Celsius. And then pressure is? Good, kilopascals or kPa. Awesome. Okay, so let's talk about the next one. It says, what does line AB represent? Explain in terms of equilibrium. So first off, AB is between what two phases? Yeah, between solid and vapor, right? So A and B is here, so it's right on this line, all right? And we need to explain this in terms of equilibrium. So what that means is, not only are you gonna have both existing, you're gonna have solid and liquid, but this is the important part. So the rate of, all right, so what's it called when we go from solid to vapor? Good, sublimation, subliming. All right, so the rate of sublimation equals the rate of, all right, what's the opposite going back? Yeah, deposition. All right, so the rate of sublimation equals the rate of deposition, which means if you have something going from solid to vapor, you would also have something going back from vapor to solid. It doesn't mean that you're gonna have equal amounts of them, but every time one changes into the other, some of the other changes back into the former, all right? It's kind of this going back and forth. That's what equilibrium means, all right? And that's what in terms of equilibrium it's talking about. What I did here was I underlined these two words because if you replace it with any of these, it means it works the same way. So for example, if we were talking about line BC, solid to liquid here, the rate of, all right, solid to liquid melting equals the rate of freezing, all right? And the same thing with the other one over there. So that's what it's talking about. That's what the idea is here with equilibrium, okay? Now, if you're on the line, that means you are gonna have both of these. You're gonna have solid and you're gonna have liquid, all right? And they're gonna stay that way as long as you're on that line, all right? Or if you're on here, you'd have both solid and vapor, okay? Any questions with that? No? Okay, what does curve BD represent? BD, liquid and vapor, right? So this would be the equilibrium between, all right, BD, liquid and vapor. Liquid and right? And by saying equilibrium between liquid and vapor, it means that the rate of boiling would be equal to the rate of condensing, all right? And then BC would be what? Solid and liquid. All right, equilibrium between solid and liquid. Okay, what is point B called? What's point B called? Yeah, it's called the triple point. Good, all right, so it's labeled in this one, good. Triple point. Bless you. Okay, so with this one, what does the term mean? Which means that you will have all three states, and then if something goes one way, melts a little, then it also will freeze a little, all right? You'll have all three of them going back and forth so that you would have all three states existing, all right? As long as you stay at that pressure and that temperature. All right, what's point D called? All the way up there, it's the highest, it's gonna be the critical point because it's also going to have a critical temperature and a critical pressure, all right? So this will break up into critical temperature and then the critical pressure. All right, it doesn't ask, but let's talk about the numbers. What's the critical temperature for this one? Yeah, 374 degrees Celsius. And the critical pressure? Good. And you're like, oh, I remember these numbers from the other day. Yeah, because we were talking about water, right? So every time, I mean, it's not going to change. Every time you see water, it's going to have these same numbers there. All right? Okay, explain what is meant by the term. Okay, so after point D, you'll notice that there's no longer a line between vapor and liquid. And that's because after you get past this, no matter how much you try to compress your water vapor, it's not going to condense back into a liquid. It's just going to stay as a gas, all right? So that's what happens after your critical point, all right? Won't condense into a liquid. Cool. All right, what is the temperature at the triple point? All right, temperature at the triple point. 0.01 degrees Celsius, and then what's the pressure? 0.611 kPa. Okay, and what is the value of Tm, the normal melting point of ice? What is the value of Tm? All right, what does T stand for? Yeah, temperature. So we're looking for the temperature, all right? So what's the temperature at the normal melting point of ice? Yeah, 0 degrees Celsius, right? So we go down, we get 0 degrees Celsius. How did we know that the pressure was 101.3? What word up there tells you to use that? What was it? Normal, yeah, exactly. Normal. Normal means 101.3 kPa. All right, because that's, so what would TB be? What would TB's? 100 degrees, yeah, because T, temperature, B, boiling, right? So when does water boil? At 100 degrees if the pressure is 101.3.